Hello, class. Welcome to today's lesson. Today, we are going to go over the law of sines. So from the feedback I got, it sounds like you did learn this in Unified 3 last year, but you learned it briefly and don't really remember it. That's pretty much what I expected. So let's go ahead and go over the law of sines today. So the law of sines is another rule that works for any triangle. So if you don't have a right triangle, if your triangle is not a right triangle, you can't use SOHCAHTOA because you don't have a hypotenuse. You can't use the Pythagorean theorem because it's not a right triangle. So that's why we have these other tools. So the law of sines says this: for any triangle, if you compare a side length to the sine of the angle that's opposite, that will be equal to the ratio of a side length compared to the sine of the angle that's opposite for any pairing of a side and the sine of the angle that's across from it. So what happens is when you fill in the numbers here, you end up with a bunch of proportions, because what you do is you take any two of these at a time and set them equal to each other. So you could set these two equal, and if you had enough numbers in there, you could cross multiply and solve. Or you can set these two equal to each other, cross multiply and solve if you had some numbers in there. Or you can set the first one and the last one equal to each other. And that's how we use the law of sines. So let's go ahead and look at our first example. We are going to use the law of sines to solve this triangle right here. So we're given that A is 10 degrees, B is 120 degrees, and little a is 5. Now, right away, whenever you have two angles, you want to make sure that you know you can find the third angle. So if you have two angles given, you can always find the third angle by subtracting from 180. Now, to set up the law of sines, what we're going to do is we're going to set up 5 equals sine of 10 degrees. 5 over the sine of 10 degrees is equal to B over the sine of the angle B, which is 120 degrees, and little c over the sine of angle C. So when we fill in the things that we know, we end up with this information. So filled in A, little a, and big A. We filled in angle B, and we filled in angle C. So what we can do is take any two of these at a time and set them equal to each other. So if we set the first two equal, we're going to be able to solve for little b. Now, a lot of you, when you look at that, will actually know what to put in your calculator right from there, especially after we've done one or two of these. But here's the full process. So if we go to set the first two equal to each other, we're going to have this proportion. And one way to solve it is to cross multiply. So to get 5 times sine 120 equals b times sine of 10. And then to solve for b, we're going to divide both sides by the sine of 110. And take a moment and go ahead and put that in your calculator, because again, the calculator can be the hardest part on these problems. And when you go to put the 5 times the sine of 120 in your calculator, you have to make sure you close the parentheses before you divide by the sine of 10 degrees, and you have to make sure you're in degree mode. If you do that, you should get 24.94. And I rounded to two places because the two decimal places because the direction said so. And remember not to put degrees on that one. That's a side length. So the side length here is 24.94. So don't put degrees. It's a really common mistake that I see pretty often. Okay. And now to find side length C, which is the only thing that's missing, we can now use 5 over sine of 10 degrees. Or since we have side length B now, we could put 24.94 there over sine of 120. You want to use what's given whenever possible. Because this is a decimal approximation, it's already a little bit off. So we want to avoid using it unless we have to. Sometimes we have to. But we don't have to use that for this problem, because what we can do is use the given information of 5 over sine of 10 degrees and set that equal to C over sine of 50. If you know what to put in your calculator right now, go for it. Otherwise, you can cross multiply, or to solve, you can just multiply both sides by the sine of 50. And if it helps you to see that work or show that work, go for it. But if you're comfortable putting it in your calculator straight from here, that's okay with me. So put that in your calculator, and you should get 22.06 for side length C. And just a quick check of our answers to make sure they're reasonable. This is the smallest angle. It should be across from the shortest side. This is the largest angle. It should be across from the longest side. Those answers look reasonable. That's not a foolproof check, but I feel pretty confident that we did well with that one. Let's move on to number 2. Okay, for number 2, I changed the letters on you. Now, changing the letters doesn't change the way this works. So using the law of sines to solve this triangle, what we want to do is set up a side compared to the sine of the angle that's opposite for all three pairings. So we want to compare little f to the sine of big F, side G compared to the sine of angle G, and so on. And you don't have to write them in alphabetical order. You definitely could write, you could write this one first, and then this one second, and this one third. They're all three are equal to each other. And now fill in the information that you know. So looking at this setup, when we go to solve, we have three unknowns. We have angle G, angle H, and side H. For this example, what do we have to solve for first? We have to solve for angle G first because this has two unknowns. So the first setup we're going to use, the first pairing of these ratios to make a proportion are these two, because this equation only has one unknown. So if we cross multiply, we can isolate the sine of angle G by dividing both sides by 8.2. And from here, I would use the calculator. So what I would personally do, you can do sine inverse right away and do the whole thing. So you could do sine inverse of 7 sine 110 over 8.2. It's not too difficult. Well, I messed it up, so I guess it is. I hit sine instead of sine inverse. So you can put the whole thing in your calculator if you want. I tend not to do that. What I prefer to do is put this fraction in, careful with the parentheses after the 110. And then I do sine inverse of the answer. That's my personal preference because it's less to put in the calculator at once. And again, to get that previous answer, it's second negative. Second negative will bring up that previous answer. And we get 53.34 for angle G. Don't forget to put degrees on there. And now we have to solve for the two missing pieces that remain. So when we go to look at using the original, because we want to use what's given whenever possible, and setting that equal to h over sine of angle h, you may notice that we have two unknowns. So sometimes people think, oh, I'm stuck. I can't solve this. I have to find a different way. We can solve this because once again, the key is remembering whenever you have two angles in a triangle, you can automatically solve for the third because all three add up to 180. So if you go ahead and do that, you'll end up with 16.66 for angle H. Now, if you plug 16.66 in for angle H, you have a proportion that you can solve because this only has one unknown, little h, so you can solve that. Just notice that I did use the approximately symbol at this point because this is now not exact because the 16.66 was already an approximation. So this is an example where we have to use an approximation in our calculations, and that's okay. If we have to, we do it. So go ahead and solve that. If you can go straight into your calculator, that's great. If you'd be more comfortable doing the algebraic work to solve for h first, that's fine as well. And once you put all that in your calculator, you should get 2.50 or 2.5 or 2.5. And I'm just going to throw that in the calculator real quick. 8.2 sine 16.66. Close those parentheses before you divide by the sine of 110. And that's our answer. All right. So that's the law of sines. One thing you're probably thinking is this is so much easier than the law of cosines. Yes, it is. It's less work. It's less algebra for solving. And these are not the only ways to solve these triangles, by the way. There are other ways you can use geometry to figure out the answers. But what we're looking at in these two lessons is law of sines and law of cosines. So that's why I use the methods.